Now we'll actually talk about how to evaluate a limit as x goes to infinity or negative infinity of a rational function. So first of all, remember a rational function, let's just call it, oops, let's make sure I have some pen on. R of x is equal to a polynomial divided by another polynomial. Okay? Now, to find the limit, we're going to divide every term in the numerator, so the top, and the denominator by the highest power in the denominator. So if, for example, if x cubed is the highest term in your denominator, you'll divide every term by x cubed. Okay, so number one here, we want to find the limit as x goes to infinity of 2x cubed plus 7 over x cubed minus x squared plus x plus 7. Okay, now our highest power in the denominator is x cubed, so we're going to divide everything by x cubed. So we're going to say the limit as x goes to infinity of 2x cubed over x cubed plus 7 over x cubed over x cubed over x cubed minus x squared over x cubed plus x over x cubed plus 7 over x cubed. Now, the important fact to remember for all of these, the theorem we had on the previous video, was that the limit as x goes to infinity or negative infinity of 1 over x to the r equals 0. And it doesn't matter from our limit laws if we had a different number up here, you know, if you had c, 5, whatever, you would just have c times 0, which would be 0. So anytime we have a number over a power of x and we're taking the limit as x goes to infinity or negative infinity, that limit is 0. Okay, so here, if we kind of reduce each of our pieces, we have the limit as x goes to infinity of 2 plus 7 over x cubed over 1 minus 1 over x plus 1 over x squared plus 7 over x cubed. Now, anything that has a denominator still, a power of x in the denominator, well, that limit goes to 0. So this part goes to 0, this goes to 0, this goes to 0, and this goes to 0. So our limit here is 2 over 1, or 2. Okay, let's do number 2 here. So here we've got the limit as x goes to negative infinity of 3x plus 17 over x squared minus 2. So here we can divide everything by x squared. And the negative infinity actually doesn't impact anything at all. So we're going to have 3x over x squared plus 17 over x squared over x squared over x squared minus 2 over x squared. So if we reduce each of these pieces, we have 3 over x plus 17 over x squared over 1 minus 2 over x squared. Now again, any of those pieces that still has an x in the denominator is going to go to 0. So this is going to 0, this is going to 0, and this is going to 0. So we have 0 over 1, or 0. Okay, and our last example here, we have the limit as x goes to infinity of x to the 4th plus 2 over x cubed plus x squared minus 1. So we're going to divide everything by x cubed. So we've got the limit as x goes to infinity. So here we have x to the 4th over x cubed, because remember we divide by the highest power in the denominator, plus 2 over x cubed over x cubed over x cubed plus x squared over x cubed minus 1 over x cubed. So if we reduce each of these pieces, we have the limit as x goes to infinity of x plus 2 over x cubed over 1 plus 1 over x minus 1 over x cubed. Okay, so all the pieces that have an x in the denominator are going to go to 0. And this leaves us this time with the limit as x goes to infinity of x over 1. Well, what happens as x goes to infinity of just x? Well, we're saying x is getting larger and larger and larger and larger. X goes to infinity here. Okay, so you may have already kind of known these rules and known how to get these answers from pre-calc or a previous class. And now you know how to use limits to get them. So here for a rational function, your horizontal asymptote, you just take the coefficients if the powers are the same. So here we took 2 over 1 because they were in the numerator and the denominator was both x cubed. When the power is higher in the denominator, like in our second case, the answer will always be 0. And when the power is higher in the numerator, it will be infinity or negative infinity.